Hey guys, this is the spiral review for your first spiral. This is going to only have one section on it, and that's right triangle trig. It might be nice if I was not in pen mode as I tried to move this. There we go. First up, we've got to solve some right triangles given some pictures. First thing I might do here is realize that I've got an angle of 90 and an angle of 33. That means this other angle is going to be 57. Apologize for the messy handwriting today. I'm writing on my phone. I don't have my iPad with me. From here, I might try to figure out what that value for x is. I'll stick with the original angle that I started with, and from here, this is my hypotenuse. Here's my adjacent side. This is the opposite side. Since I'm looking for the hypotenuse and I have the opposite, I'm going to use sine. So sine of 33 degrees is equal to 21 over x. I'm going to multiply both sides by x to get x sine of 33 equals 21. And divide both sides by sine of 33 in order to get x by itself. So we get x is equal to 21 divided by sine of 33. You're welcome to leave your answer like this, but if you'd like to know an answer that makes a little bit more sense to us as human beings, you can use this on your calculator. And in doing that, that would be 38.56 degrees. I'd also like to get that other side, and for that I might use the Pythagorean theorem. And to do that, we have the square root of 38.56 squared minus 21 squared. And when I do that, I get about 32.33. For the second problem, we're trying to find an angle and another side. If you don't recognize this as a special right triangle immediately, that's okay. I know that based on this angle, we have the opposite and the hypotenuse. I might deal with this as sine. So we've got sine of question mark is equal to 9 over 18. If I were to use arc sine or sine inverse, we get 30 degrees. Okay, so question mark is 30 degrees. That means a couple of different things. It means that this other angle is 60, and that we're looking at a 30, 60, 90 right triangle, which has some special relationships. We know that the hypotenuse is twice as big as the short side. Okay, that's true there. And that the longer leg is going to be the short side times the square root of 3. You're also welcome to use the Pythagorean theorem to get that value, or to use the decimal equivalent of that for this. A little bit later in the year, that will not be okay to use the decimals for that. Okay. Next one, we've got sun at an angle of elevation. We've got a tree. I'm going to draw my very expertly drawn tree. There's my tree. And it casts a shadow on the ground. Somewhere off here is the sun. So what's going on here is we have an angle of elevation of 58 degrees. That's the angle from the ground looking up. And the tree casts a shadow that's 20 meters long. What we need to do is to figure out what this height is. So looking here, this is the opposite, the adjacent. I'm going to use the tangent ratio based on these two sides. So we're going to have tangent 58 is equal to x over 20. If I multiply both sides by 20, I get 20 tan 58 is equal to x. And actually, I can stop right there. If instead I wanted to find the value for that, I could use the calculator, and I get x is equal to almost 32 on the dot, 32.00669. So that's pretty close to exact. Our last problem on the review. So we have someone starting out 17 miles from the base of a tall mountain. Here's my tall mountain. 17 miles from the base is going to be right here. And they look up at an angle of elevation of 4 degrees. So here's your 4-degree angle of elevation. When they move 12 miles closer to the base, so now suddenly they're like here-ish, what will the angle of elevation be? So we want to find a second angle of elevation here. I'm going to treat this as two separate triangles instead of looking at this once. I'm going to show this second mountain. So we have the same mountain. It's going to have the same height. We don't know what that height is yet. We don't know what that angle of elevation is yet. But 12 miles closer from 17 is going to be 5 miles. Our goal here is going to be to figure out this angle of elevation. And to figure out this angle of elevation, I need to know what x is. To figure out what x is, I'm going to use the information from the other triangle to get that information. Since it's the same x in both triangles, because it's the same mountain, what we're going to do is get something pretty quickly that comes out okay. It's going to start out something like this. We have an opposite and an adjacent. Okay, so the tangent of 4 degrees is going to be equal to x over 17. I'm going to multiply both sides by 17, and I get x is equal to, in this case I'm going to use the decimals just because I have it typed out already, 2.475. So our mountain is 2.475 miles tall. I'm going to include that over here. It doesn't look like a 2 very much. I'm going to call this 2.48 just for the sake of writing less with my finger. To get this angle, we're going to recognize that we are again looking at the opposite and the adjacent. So we use tangent of that question mark, okay? Tangent of question mark. And that's going to be equal to 2.48 over 5. To figure out what question mark is, I'm going to use arctan or inverse tan. I'm going to zoom out a little bit so we can see. So arctan of 2.48 over 5, we get question mark is equal to 26.33. It's 26.34, but that's good enough for us. So what that means is that after walking another 12 miles, if you look up to the top of the mountain, you have an angle of elevation of 26.33 degrees. And I don't know why that's not zooming out with the rest of the stuff, but that's okay. And that's it for Spiral 1. I figure that I will add for you guys a picture of the dogs that you heard growling, because why not? Here we've got Winston and Groot, who are nicely making their voices heard while I talk about them.